Okay, everybody, today we're going to talk about recursion. A recursive function is a function that calls itself. It's just a different way to accomplish tasks that we've kind of already done. With a lot of things we do, you're going to look at and you're going to say, I could just do this with a loop. And for many of them, you'll be right. For the simple examples of recursion, they are often done better with a loop, done easier with a loop. However, it's hard to start with the examples of recursion that are really great uses of recursion. So we're going to start with simple examples. Again, you're going to look, you're going to say, I can do this with a loop. I don't need to learn this. The more appropriate uses of recursion you will actually need recursion for. So I'm going to ask you to bear with me. When you see it, just kind of try to follow it as just a different way to solve the problem. There are languages that don't have loops at all, and you have to do stuff like this. So the first recursive function I'm going to write is a function to just print the numbers from a given n down to one. So I'll call it printer, public static void printer. I'll say take some n. Now what I want this function to do is print out every number from 1 to n. So if I say printer of 5, I want that to print 5, 4, 3, 2, 1. So the way I do this is I print out whatever n is here. And then I call printer again with n minus 1. So I'm going to call printer with the value 5 here. I'm going to come up here, print out whatever n is, which will be 5. And then I'm calling that same function here with n minus 1. We can kind of look at how this works. So each one of these calls here, this call to printer inside of printer is called a recursive call. I'm going to draw these as boxes to illustrate that they're kind of inside of each other. I'm calling printer with the value 5. When I call printer with 5, I'm going to go to line 4, print out 5, and then on line 5, I'm calling it with n minus 1. Since we have n is 5 here, printer n minus 1 will be calling printer with 4. So inside of printer 5, I'm calling printer 4. So then we're back up at the top of printer again with n minus 1. 4 now. The n for this one is 4. Line 4 prints that 4 out, and then we hit line 5 again, and we call printer again, n minus 1 again. So that's going to call printer with the value 3. So that brings us kind of back up to line 3 with n equals 3. That brings us to line 4. We print out that value of n, which is now 3, and then we go to line 5 and call printer again with n minus 1. The current value of n is 3, so we're calling printer with n minus 1, which is going to be 2. So inside of printer 3, we're calling printer 2. Now this printer 2, again, brings us back up to the top of printer with a different n. So on line 4, we're printing out that 2. And then on line 5, we're calling printer n minus 1 again, which is going to call printer 1. N minus 1 is going to be 1. It's going to print out the 1, and then we call it again with n minus 1. So yeah, inside of printer 1, we're calling it with 0, and then printing out 0. And then we're calling it again with negative 1. So we print out negative 1. And then we call it again with negative 2. We print out negative 2, so on and so forth down to negative infinity, theoretically at least. But what I said was I want to print out the numbers from n down to 1. I don't want to see 0, negative 1, negative 2. What you have to do is you have to check for the condition that you want to stop at, and then don't recurse. Don't call yourself again if that's true. Or you can just stop yourself once you hit that condition. So I want to stop when n is less than 1. So I can say if n is less than 1 here, return. So since it's a void function, here I'm not returning anything, it's just stopping the function, and these two lines won't run. So now I have that condition here. So if I rewind where I was here a little bit, let's go back to say at the top of printer 2. I'm going to print the 2 out, then I'm going to call printer with n minus 1, which is going to call printer of 1. That prints out the 1. Then I call it again with printer 0. Now here's where we stop, because on line 4 now, I'll check that condition, I'll have n is 0. So I'll just return, I'll just exit the function. I won't run lines 7 and 8 now. So this one doesn't do anything. So we exit printer 0, or we exit printer with n equals 0. We come back out to the next scope, the printer 1, and we're at the bottom of that one now. So at that point, we just exit printer 1. So that one's done. We're going to kind of just work our way out here. So once that's done, we go back out to the printer 2. That one exits. Then 3 is going to finish. And then 4 is going to finish, and then 5 is going to finish. We're hitting the bottom of every function one after another, which kind of makes it exit the entire thing at once. So when we write code like this, we have 2 cases. We have our base case, our stopping case, and we have our recursive case, which is everything else. So down here, these 2 lines would be the recursive case. So in the base case, n is less than 1, we don't do anything. And the recursive case, we print out n, and then we recurse, we call ourselves with n minus 1. If I run this now, I should see the result. If I ran it before, I would get that down to negative infinity kind of thing. This is one of those things that some people just kind of get. I honestly wasn't one of those people. Recursion was a tough concept for me. And other people, like myself, will just see it, and it'll be really weird until you play with it a lot. You would have to check the condition first, because if I check the condition after here, it doesn't really make any difference, because that means we'd always call ourselves. And there has to be a point at which you don't call yourself again. So another thing we can do recursively that we've done with the loop is printing out the elements of an array in order. So for that, I'm going to write a second function. I'm going to call it print elements. So I'll have my int index, and then I'll have my array as my second argument here. This recursive function is taking 2 arguments. It's taking the index to print, and it's taking the array to print out. So the index is going to be what I'm printing right now. And then the array is going to be the entire array I want to print out. So if I create an array of numbers down here, What I want to be able to do is call print elements. I'll start it with index 0 and then the nums array. So what I can do here now is say print the current element, the element at that index, so nums brackets index. So that'll print the 0th element the first time. I'll write my recursive call with index plus 1 and the array again. I'll call it with 0 and the array, which will print the first element, and then I'll call myself with 1 and the array, which will print the second element, so on and so forth. And I'm going to comment out the call to printer down there so I don't see that 5, 4, 3, 2, 1 anymore. If I run this, I do see these all printed out. I see the elements of the array in order, 45, 27, and 300. But what I also get is an array out of bounds exception. Because what's happening is when I'm doing this kind of boxing thing, I'm calling print elements. I'm just going to write print e for brevity here, 0, and then nums. So that is the first call. That's going to print out the element at index 0. So the 45 gets printed. Then inside of there, I have a recursive call. I'm calling print elements with 1 and nums. That one's going to print 20. Inside of that one, I'm calling it again, this time with 2 and nums. So that one will print, again, we're on line 4 is where all the printing's happening. We'll print out the element at index 2, which is going to be the 7. And then I'll recurse. I'll call it with 3. So back up to the top again. Index is 3, so I print out the 300. And then I call it again, 4 in nums, and now that one's going to try to print the element at index 4. The index 4 is 1 past the end. We only have elements at index 0, 1, 2, and 3. 4, the length of the array, is off the end of the array, so that's why I'm getting an out of bounds error. So it prints the first 4, and then when I try to print out the element at this index, that's what this 4 means over here. That's the index that's trying to print out, giving me that error message. Array index out of bounds exception, that's the index. And then down here it says main.java line 4. That is where the error is coming from. That's where I'm doing the wrong thing. So what I want you to do is take a minute and try to figure out if you can write the base case for this one. So we already have our recursive case. Let's see if you can figure out how to write the base case for this so it doesn't go out of bounds and it still prints all the elements. What's the base case going to be for this? When do we stop? If it makes it clearer, you can also print the index explicitly. So instead of just that, I could say index plus a colon space plus the thing. So then I would see the index before the element. So you can see which numbers are being printed out or which index we're dealing with at a certain point. And I make it more obvious at what point you have to stop. So like there's a base case in this printer one, what's your base case here? It's going to be an if something and then a return. But you just have to figure out what that condition is. So just try different things. What is the index that we fail at? In this example, which index is the one that causes the error? We print out 0, 1, 2, 3, and then we crash on 4. Index 4 is the problem. So that means we need to stop when the index equals 4. Then what is the significance of 4? Because this should work even if we have a different size array. So you're going to have if index something. What you want to realize is what is the point at which you break, and it's 4. It's when the index equals 4. So that's our base case. We can just say if index equals 4, return. If index equals 4, return, right? But 4 only works because the array has 4 elements. We want to do it more flexibly. We want to stop when the index is equal to the length of the array. So if the current index that we're running with is equal to nums.length, then we return. So in this example, when we come into print with 4 in nums, that condition will be true and we won't run. We'll just go back up outside, we'll unwind all of this, and we won't try to print anything else. We won't recurse, we won't call ourselves again. So when the index equals the length of the array, stop. Now it's time for you guys to do one. I want you to write a recursive function that instead of printing the numbers 5, 4, 3, 2, 1, I want you to do it the other way, where I give you a number and you print like 1, 2, 3, 4, 5. If I say print up 5 or print up 0, 5, you can do it either way. So you can do it where you just take 1, or what might be easier is you do it similar to the print elements one. It's like the one that you're printing and then your upper bound. I can call it with print up 0, 5 or 1, 5, and then that should print 1, 2, 3, 4, 5, and that's probably the more straightforward way to do it. If you get an error, I can just kind of show you what it looks like. So let's say I run printer without the base case. You're going to get an error like that looks like this, where you just have this huge thing that has the same line number over and over and over again. It'll say like main.java something. It might not be 17. If you scroll up far enough, you're going to see something that's a Stack Overflow error. Anyway, if you get an error that looks like that, it means you just don't have a base case or your base case isn't stopping at the right point. This thing right here where it says exception Stack Overflow error. It's easier to kind of tell if you just see the same line number repeatedly. Would probably want to do it this way where you say static void print up and then int n, int max, for example, and then fill it in here. So there's the two cases you have to think about still. I can say this is my base case. Down here is my recursive case. So what are your base case and your recursive case here? I'm seeing people doing things like putting a plus plus inside the recursive call. Like instead of printer equivalent would be instead of writing n minus 1 here, they're writing minus minus n. Kind of works, but it changes the value of n. N minus 1 is what you want here. Because you're not trying to decrease the value of n and then pass the new decreased value. You're just calling it again with one lower number. So I can fill in my recursive case here. That is going to be where I print out that n, and then I call myself again with n plus 1. But I can't just pass n plus 1. I need to pass the max as well. So that's the recursive case. What is my base case? If n is equal to the max, then I just return. So now I see that 1, 2, 3, 4 down here. So right, we have an exclusive upper bounds. If I wanted an inclusive upper bounds, it would be n is greater than max. And I should see 1, 2, 3, 4, 5. And then I get the array elements. The main, I just have a print up call here 1, 5. There is another way to do this where you don't have to pass this extra value. I don't have to have this extra n. So to write that, I'm going to make a second one called print up 2, and that's just going to take the max, or I'll call it n. Now, this is going to be really similar to the way I did print up, where I print out n, obviously. My recursive case is still going to be to call myself with n minus 1, and then my base case will still be the same. It'll be n, if n is less than 1, return. So at this point, I have like a duplicate. So if I say print up 2 here with just 5, I'm going to see that 5, 4, 3, 2, 1 again. The way I can actually change this to print them in the other order is to switch lines 7 and 8. 1, 2, 3, 4, 5. So if I switch these two lines, instead of 5, 4, 3, 2, 1, I get 1, 2, 3, 4, 5. Because what happens now, I come in here with 5, then on this line, before I print anything, I say print n minus 1. So then I'm asking print 4. Before I've printed 5, I call myself with 4. Then it comes back up here with 4. Then it says print up 2 with 3. Then it comes back up here with 3. Then we're down here again with 2. So print up with 2. Comes up here again. Then we call it with 1. Then we're up here with 1. Then I call it with 0. Now, I'll call it with 0, which makes this condition true, which returns. And when we return from a function, we go to the next line after where we were called. So the next line after print up 2 with 0 is this line with n equals 1. And then we hit the bottom of the n equals 1 case. After printing 1, we go out to the n equals 2 box, which then prints 2. And then that exits, and then that prints 3. And then that exits again back up to the 4 box, and then that exits and then up to the 5 box. So just by switching the order of these two lines, I switch the order of the way these things are printed out. Because the way you think about this is I say print everything less than me, then print myself. And you just make that decision for every number. Every number says before I print myself, print everything less than I am. It sounds kind of vague, but when everyone follows that sequence, everything works out. The next thing I want to do is something a little more mathematical, which involves functions returning something. So very basic math kind of thing, nothing crazy. Factorial of a number and then exclamation. So 5 factorial means 5 times 4 times 3 times 2 times 1. So I can write 5 factorial equals 5 times 4 times 3 times 2 times 1. And then 4 factorial, if I were to write that out, would be 4 times 3 times 2 times 1. 3 factorial is equal to 3 times 2 times 1. 2 factorial is equal to 2 times 1. 1 factorial is just equal to 1. If you look at what's up here and you look closely, you'll notice that I'm repeating things a lot here. This whole thing here is the same as this whole thing here. 4 times 3 times 2 times 1 is here, and it's also down here. Just like this 3 times 2 times 1 shows up here, and it shows up there as well. So you can also define factorial a little bit differently. Instead of saying 5 factorial equals 5 times 4 times 3 times 2 times 1, I could say 5 factorial is equal to 5 times 4 factorial. And it's the same thing, because 4 factorial is equal to 4 times 3 times 2 times 1. So 5 times 4 factorial. And you can just kind of work your way down defining them all like this. 4 times 3 times 2 times 1. Well, 3 times 2 times 1, that's just 3 factorial. And 3 times 2 times 1, that second part, that 2 times 1, that's just 2 factorial. And 2 times 1, well, 1 is also 1 factorial, and 1 is 1. Our recursive function can also be expressed as something defined in terms of itself. 5 factorial is 5 times 4 factorial. 5 times the factorial of everything less than 5. 4 times 3 times 2 times 1. So 1 factorial equals 1 is a base case. There's nothing we compute there. We just know that it's 1. And as we work our way up, we can know this. So 1 factorial equals 1, and then 2 factorial equals 2 times 1 factorial, which is just 2. 3 times 2 factorial, well, we know that's 2, so it's 3 times 2, which is equal to 6. And 4 factorial is 4 times 3 factorial. We know that answer now, that's 6. That means that this result is really 24. 5 factorial equals 5 times 4 factorial. 5 times 24 is 120. So we can define this in code very similarly. If I wanted to define factorial this way, instead of using the exclamation point syntax, I would just say n times the factorial of n minus 1. That would be the recursive way to write this. So a factorial function would be int fact for short, int n. And inside of here, I would want to return n times the factorial of n minus 1. What did I say my base case was? What's the thing you know already? 1. So if n is less than 2, I would just return 1. So this is my base case, and this is my recursive case. N is less than 2, so 1 or 0. Factorial will just be 1. But anything else, we define it as n times factorial of n minus 1. So that there, n times factorial of n minus 1, is the same as 5 times 4 factorial. It's the same kind of idea. And if I modify my main to call this now, I can figure out the factorial of 5, 120. If I want the factorial of 6, 720. Factorial of 7 is going to be 50, 40. So when I enter this, when I'm trying to figure this out, I'm doing that same thing where I go inside of another box over and over and over again. So I want to see how the factorial of 5 is computed. Let's call to factorial of 5. This is going to return 5 times factorial of 4. So we'll have to draw another box in here for that factorial of 4 run, where we'll have factorial of 4. This one is going to return 4 times factorial of 3. And we'll draw another box inside of that. Factorial of 3 is going to return 3 times the factorial of 2. And we'll draw another box inside of this, factorial of 2. Each one of these things doesn't know what its result is until all the ones inside of it run. And then it computes the real results on the way up. So we'll have factorial of 2 here, which is going to be 2 times factorial of 1. And then finally, I'll have factorial of 1, which is just going to return 1 because that's our base case. So factorial of 1, that condition on line 5 is true. So I just hit that return 1 line. This 1 here is what comes out of that box and it replaces this right here. So factorial of 1 here is just 1, and this inner box goes away. 2 times 1 is just going to resolve to 2. So factorial of 2 now returns 2. 2 comes up here, it replaces the factorial of 2 on this line. So that's the result of factorial of 2. It's 2. So this inner box goes away. We're done with this one now. We're going to return 3 times 2 from factorial of 3, which is going to be 6. So now we're returning 6 from here. That comes up here, replaces that one. So we have a 6. This box goes away. We're returning 4 times 6, 24. The factorial of 4 is going to return 24 now. That's going to come up here and replace factorial of 4. And we get 5 times 24 is equal to 120. So we return 120, and that comes out of factorial of 5 to where we originally called it, which was down here in the main. And then we print out that one value. So we're going inside these boxes over and over again, trying to compute these sub-problems, and then doing that multiplication on the way back up. One thing to notice about all of these is that I don't actually change the value of any variable at any point. I don't change what n is anywhere. I don't change what nums is. I don't change what index is. I just call factorial with a different n. So when you can't change the state of things, and there are languages where you can't do that. Like there's functional languages where you don't have variable assignment. You can also write it as a ternary and just say return n is less than 2, 1, otherwise n times factorial of n minus 1, and that gives you the same thing. So it makes a nice little one-liner. There's a sequence of numbers called the Fibonacci sequence. This is the Fibonacci sequence we're going to follow because it makes a little more sense for us. Can anyone tell me what the significance of these numbers are or how you'd figure them out? It's the sum of the previous 2 values. 2 values, you add them together, and that's what gives you the next one. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, 21 plus 13 is 34, etc. So it's just the previous 2 numbers. So we can define this recursively. We're given that the Fibonacci of 0 is 0 and fib of 1 is 1. One thing to just notice here also is if you're trying to test this, if you're trying to write this code and test it, fib of 5 is also 5. So it's just a weird one. Don't test with 5 because it would be the same as if you were just printing the value itself. So the Fibonacci or fib of some value n is equal to fib of n minus 1 plus the fib of n minus 2. We also have the base case where if n is less than 2, it's just equal to n. And this isn't obviously Java code. So if it's 0 or 1, it's just 0 or 1. Fib of 0 is 0, fib of 1 is 1. And those are the base cases we're given. So if I wanted to convert this to Java code, how could I do that? I want to write a function called fib. So public static int fib, which takes some value n, and it returns the Fibonacci number. So what's our base case here? What are the ones we already know? We know 0 and 1, right? If n is less than 2, what do we want to return? N itself. So if we get a 0, we return 0. If we get a 1, we return 1. Otherwise, what are we returning? It's just as I've defined it right here. Fib of n minus 1 plus fib of n minus 2. So now I can say, what's the fib of 7 and 13? And that is right. So we have 5, 6, 7. So 7 is 13. That's the right number. Now, I will tell you that this is very slow, but it is a good explanation of how we can do something recursively, how you can define something in terms of itself. You can do this with a loop as well, and you honestly probably should, but I think it lends itself to a recursive definition really nicely. When looking at how this actually executes, you'll have something called a recursive tree, where we're computing the fib of, let's say, 5. Before we get that, we have to compute the fib of 4 and the fib of 3. And then to get the fib of 4, we need to compute the fib of 3 and the fib of 2. And to compute 3, we need to figure out 2 and 1. And to figure out 2, we need to figure out 1 and 0. 1 we already know, so we don't have to compute anything for that. We don't have to compute anything for that or that. On the other side for 2, we need 1 and 0. Both of these we already know, so we don't have to do anything there. On the right side, we need 2 and 1. For 2, we need 1 and 0. And 1 we already know. So everything at the bottom here, you'll notice they're all the base cases. 1, 0, 1, 1, 0, 1, 0, 1. Then you work your way back up. The fib of 2 is going to be fib of 1 plus 0. So the result of that is going to just be 1. This one will be 1 plus 1, so we'll have 2 here. 2 over here. We'll have 1 here. We'll have 0 here. That gives us 1. That gives us 1. That gives us 2. And then we have 5. So fib of 5 is 5. Again, I kind of rushed through that because it's like the end of the class, but this is how you can define Fibonacci. Other than that, have a great day.